Hello, I'm going to talk about IPv4 subnetting now. Hopefully you've already done a fair bit on binary to decimal conversion and vice versa, so I can get a feel for these 8-bit numbers in there. So there's an 8-bit number there, 8-bit number there, 8-bit number there, 8-bit number there. 4 octets, each one's called an octet, and they form the basis of our IP addresses. So in this case, just to lay the foundations just here, I've got this IP address 192.168.10.1 and the subnet mask of 255.255.255.0. So each of these values is converted up into binary, and we'll do this in a minute and talk about what we're doing. So binary to decimal conversion, what we need, so we can convert these numbers into binary. And hopefully you've also had a bit of a crack at the AND function, so you understand how the subnet mask works with the binary or the IP address to formulate a network number. So let's just chuck in our IP address here. So we'll start off with, we're mostly with subnetting is looking at network numbers and a few rules around that. So let's start off with a classic C-class address 192.168.10. and the subnet mask of 255.255.255. So let's put it in binary up here. So 192 is that. 168 is 128 plus 32 is 160, and then 8. So we'll chuck a few zeros in there. So if you're not comfortable with this, revisit binary to decimal conversion before we go too much further. Let me just center all this, sorry. Love being prepared, don't you? So the last one is 10, so we're converting 10 in decimal into binary. And 8 plus 2 equals 10, and then 1 is our only odd number, and he puts a 0 there, so there's a 1 in that. Just copy that 0 right across, we'll cheat. Well done. Okay. Oh, please, yes. Okay. So there's our values. 192, 168, 10, and 1. And we now need our 255.255.255 in there. So that'll be all ones. In there, where'd the 4 come from? It doesn't exist in binary, so that equals 255, and now the last one is all zeros, because that's all 0, 0 as well. Okay, so up in there, that's the binary. We won't go into this, we're just using the decimal for the last octet there, so that's decimal 0. That's a 1, and so far so good. Now, that's our subnet mask, that's our IP, and what we need to do is actually work out our network number. So if you work through the ANDing function, which is what's used to determine our network number, we would know that where there's a 1 in the subnet mask, right across there, we will take the value that's in the other input to the AND function and just move it straight down. That might not have been clear, but all we do is take that exact value of our network number, of our IP address, sorry, where the 1s finish, that's where it stops, and then right across the end here, it'll always be zeros. So in the ANDing function it says if one input is 0, the output will always be 0. And if one input is 1, then the output will always match the other input, is another way of saying it. So there we have it. That is our network number. And that's the key to everything. So 192.168.10.0 is our network number. And our PC will use that number to determine whether or not we're pinging or trying to access another machine on our network. So on our network means the same number, same network number. And if it's not on our network, then we will send whatever we're connecting to, whether it's a ping or something, to our router, our gateway, and that router will send it off. The router routes based on network numbers, not IP addresses. You will see some IPs in a router, but it routes mostly on matching a network number. And it doesn't have to be a full network number, it can be a subnet or a supernet or something else, but that's what we're here to learn, is these differences. Okay, so there's our network number, and there's our IP address and our subnet mask, all in binary. Now the rules come in. Where our host portion, so down the end here, this is our host portion. These numbers always have to be different on our networks. So if you have an IP address of 1, then the next IP address available is 2, then 3, then 4, and onwards. But there's 2 addresses we cannot use, and that is this address, which is all zeros, which is our network number, and the other one we cannot use is all ones in this portion, because that is the broadcast address for this network. So all the prefixes still say the same. So the 2 numbers we cannot use as an IP address in the host portion, so let's just host portion, and in our case here, this is our, not too sure what I did there, network portion, as defined by our subnet mask. Okay, so the host portion, that light blue stuff, everything in there is all zeros in our subnet mask, therefore they will be different numbers. So back to that. The numbers I cannot use, all zeros in the host, because that is my network number, and we have to have unique network numbers in IPv4. And all ones is also the broadcast for this network. So across my network, if I want to send a broadcast to every device on that network, I'll send the broadcast to 192.168.10.255. Excuse me. So those are 2 rules we have to follow. Now the range of values in between that we can use goes from the first value to the last available binary value, and that's it in binary there. So pretty much it means add 1 to the network number, which is what I did there, and subtract 1 from the broadcast, which is what I did there. And that's important rules to remember, because later on we won't have a broadcast that's all ones in the whole octet. It won't be a 255, it'll be something different, and that's what we're doing with subnetting. Okay, so let's go back to it a bit. Quick refresh. We plugged in this IP address 192.168.10.1 into our computer. We put in this subnet mask 255.255.255.0, and from that the computer has worked out that this is our network number, 192.168.10.0. How did it work that out? It used the AND function. And the AND function says, I think I've still got it on the side here. There it is. Good. If my input is 1, then my output will match the other input. So if my network mask is 1, then my output will be the same as my IP address as it goes through. So where there's a 1 there, I've just moved that number straight down. 1 and 1, 1, 1 and 0, 0, all matched in there. If you're not sure about that, revisit and then come back. Now, where my mask is 0, my output will always be 0. So there we have our mask at 0 all across there. And what we said is my network number has all zeros in that portion, which is the host portion. So that's the ANDing function gave us that. Okay, so let's pop back into this. So the ANDing function, along with my subnet mask and my IP address, gave us this network number. Good. From that, we then add all 1s in the host portion that's left, and that becomes the broadcast address for that network. And in our case now, it's 255, which is 8 1s. Then we said, okay, what valid IP address range do we require or can we get from this system, this network? So we added 1 to the network number to get our first IP address, which happens to be the same as the actual IP address that we put in. And then we subtracted 1 from the broadcast address to get the last available IP. In this case, we end up with 254 available IP addresses. So anything in between that is valid. So 10, 251, 125, all are valid IP addresses for this network, 192.168.10, with a subnet mask of 255.255.255. And if you can follow these rules, then you're set. So that's the basic structure that we play with our network numbers. Okay, 12 minutes gone into our little lecture there, so I'm going to jump in. There'll be another lecture on classful addressing, and we'll go through this stuff as well in there. But what I'm going to do is now subnet. So what I do is I'm going to wipe out all those values there. And what I'm going to start with is the network number that we originally have. So 192.168.10. And I say I'm going to create more networks out of this single network. I'm going to create sub-networks. And we do it by actually extending the number of bits in our subnet mask. So at the moment we've got 255.255.255 as my subnet mask. What I'm going to do is extend it. And in this case, I'm going to just add, oh no, I'll add 2 bits to it and see what the outcome is, and we'll go through that process. So I'm going to add 2 bits to my subnet mask. These 2 values here become a bit different, so I'll just put them up in yellow. They are now kind of floating in the breeze, and we'll come to them in a minute. But let's just have a look at this value here. So all we've done is said we've got a continual row of 1s. We can't have any zeros in here. And I've just extended it by 2 bits. Let's make that a nice color as well. Make that orange. The whole parent side has stayed the same. Nothing's changed in there. That's called supernetting if you go that way. We're going subnetting. Okay, so I've put 2 extra bits in my subnet mask. What effect has that had? I'll just say one thing. It's reduced the host portion. So let's undo this, and we're just saying that now our host portion is actually that long. We'll give that a color as well. There's a nice pink, isn't it? My network portion has now increased. And we'll give that a color as well. There's a nice color out of this. It's green. Okay. So my network number is now longer and my host portion is shorter. And this is perfectly valid. It's quite nice to do. What we've actually done is created 4 new networks. So where have these come from? It actually has come from these 2 bits up here, these 2 yellows that I've got. Because I've extended my subnet mask across there, these 2 values have become network numbers. Now we can use 0 and 0 as 2 values, but we've also got 0 and 1 as another 2 values, 1 and 0 as another 2 values, and 1 and 1. There are 4 different options in there. So there are 4 new networks because I've added 2 bits. The math for that is 2 to the power of 2 gives us the number of networks that we end up with. And there they are. What I've done is said, what is the full range of binary values for those 2 bits? And it is 00, 01, 10, 11. And that's actually how we should write them. We're almost adding a 64 to each one of those because 64 is the lowest value in this area. So let me just copy this, and what we've said is we've got 192.168.10.0 there, and 192.168.10 again, and in this case 164, 192.168.10.128, and 192.168.10 and 128 plus 64, 192 is the values there. Now in our network numbers, I've said previously that when we AND everything and our subnet mask is 0, then this is all going to be zeros down here. So all zeros, all zeros, all zeros, and all zeros are our network numbers for those 4 networks. So what are the actual network numbers? I'm going to move over just a tad here and squish this out a bit. So this network number up here is 192.168.10.0. It's the same as the parent. Always the same as the parent. So you remember the parent was that one? Well, it wasn't. It's got a 1 in it, but it was that. So digress. So what's this value here? So this network number is 192.168.10.64 is the network number. There's a 64 there. 164. No 128s, no 32s, no 16s, no 8s, no 4s, no 2s, no 1s. 164. That is our network number because our subnet mask now finishes down this line here. Next network number, 192.168.10, same prefix, and this is a 128. There's 128 there, and all zeros. The last one, 192.168.10.192, is my network number. So 192 is 128 and 64. Now this is the kind of stuff you need to practice. We need to work out our network numbers, and then we need to work out our broadcast addresses and our range of hosts and all that sort of stuff, and that's the next bit we're going to go into. So for each of these networks we should work out what our ranges are. So what I'm going to do is move these, actually what I should do, let me just create some space here. Let me just insert a few. I'll insert another set of rows below as well. Okay, so this first network is fine. Let's take that lot there and pop it down there. So what I'm doing is just separating my 4 networks out and just messing around a wee bit. And let's hopefully we get enough space. 1, 2, 3, that was there, 1, 2, 3 there. And I think I need to add let's just have another couple in there. Okay, so now I'm going to color these a bit differently just to make it look interesting. So we're going to need that lot, and we'll make it all yellow, and we'll put a little box around it, and we'll make this lot, so we need that lot to be colored differently. And then this network number, I should put boxes around that one, shouldn't I? I'll come back to that. So a little bit messy what I'm doing, but hang in there. Wow, that's bright. If that's not hurting your eyes, and nothing will, so I'll come back and change that. Let's go for something a bit more passive now. Let's go grey. Okay. We'll go back to this. Sorry about this. I'm not used to. I'm just trying to learn a bit more LibreOffice actually. Let's go for a nice lighter colour. Okay, so let's pop back into there, and we'll make nice little boxes around it. Not the border style. We want that one. Okay, so I've just coloured up my 4 networks, and we'll play at the end here because that's where we want. So what we've done so far is we've said let's add 2 bits to our subnet mask, and that's moved the network portion of my address across. But because we've taken over 2 host bits, we need to create extra values for different networks. So these are 4 now new networks, all under the same length subnet mask, and now we need to work out their ranges, and the ranges are based on the host portion. So that block in there is the host portion for this network, this 192.168.10.0 network, which lives all the way back there. And you'll notice something, even though I've talked in decimal at 192.168.10, the computer only ever looks at zeros and ones. So if you can get your head around the zeros and ones and where they just end and start and all the rest, and then convert that value back, then you're done. Okay, so what are the rules that we've got for our networks? Well, the first one is these are our network numbers, and they have all zeros in the host portion. We cannot use that. The other rule I said is all ones is our I'm trying to think and work at the same time. It's not good, is it? All ones is our broadcast for that network. So that network number there is the value that we have now, and all ones is that value. So the broadcast for this network now is 192.168.10.63. I even forgot to do that side. Okay, good. Now there's a couple of things in that. Let's add these up. 1 plus 2 plus 4 plus 8 plus 16 plus 32 equals 63. It's actually 1 less. It'll always be 1 less than the next network number if you've had a look at that. So if you got into binary maths and you added 1 to that value, you'll actually end up with this value, which is the next network number. Or we go longhand and we add 32 plus 16 plus 8 plus 4 plus 2 plus 1, so 63. Just quietly, in the fourth octet, your network broadcast will always be an odd number, and your network numbers will always be even in that fourth octet. Okay, so there we've added up those numbers. Now what I said before is the first available address that we can use is to add 1 to the network number. So let's do it from here, 168.10.1. So that's my first IP address that I can use. And I said that the last one was 192.168.10.62 would be the last address because it's one less than the broadcast. So let's pop that in. So 192.168.10.62. Now is that true? Let's add 1 in binary to this lot. 1. Now I'll just play in this last octet, which actually does finish on this line here. It's not a very good line, but we'll put it in. So it's 0, 0 to start with. So never forget that 0, 0 that comes in there. And we'll put that 0, 0 because that's our network numbers in there as well. So is that number the number 1 for the 4th octet? So all zeros and a 1 at the end? Yes, it is. Now if I take 1 off this value, then that means that that's a 0. And we move that way. And we add up that number. So 32 plus 16 is 48. I do it slightly differently. So 48 plus 2 equals 50 plus 8 plus 4. So it's plus 12. So 50 plus 12 equals 62. You've got to work out your own style there. So correct. Good. Let's do it for the next network below. So in this case, now we'll just copy down our network number. Oh, jeepers, I hate you. Never does what you want, does it? Control V. Yes. Control copy. Control V. Copy. V. Okay, so what I've done is just for the last octet is I've copied the last bits down. So that's a good value in there. Why didn't anybody tell me that was wrong? Okay, so I've said this is my next network number. We've worked that out a bit before. So where should we start? Well, let's put all 1s in the host portion because that's our broadcast. I've said it's 1 less than the next network number. So if we add 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you will end up with 127. So the number here will be that value. So what's our next IP address? Well, what is the IP address range that we can use in this network? So we can't use the all zeros in the host portion. We cannot use the all 1s in the host portion. So let's go through and check in the range. We add 1 to the network number, which is 64. So 192.168.10. I did it again. 168.10.65 is going to be our first host address. And the last one is going to be 192.168.10.126, which is the last host address. So for this network, we're going to run between 192.168.10.65 up to 192.168.10.26. There are 62 available hosts in that network. There's 62 available there, and because this is all fixed length subnetting, and we're not doing variable length at the moment, then there will be 62 in each of these networks. So let's have a look at this last one. I've said that my network number down the bottom should be 1 less, the network number is 128, we've worked that out already. The broadcast should be 1 less than the next network number. So 192.168.10.191, and the first available host in this network, 192.168.10.129, and the last one, 192.168.10.190. So that should be correct. Let's go back into here and have a look. Let's add our ones together. Go back. So one way of working this out is we've actually 64 less than 255, aren't we? So let's just do a bit of math. So equals 255 minus 64 equals 191. That is correct. A little trick with it. Let's add 1 to this value, so and a 1. So 128 plus 1 equals 129. Good. And the last available network IP address is 1 less than the broadcast, because this is just our host portion there. So 1 less says 191 minus the 1 equals 190, so we're good with that. Okay, let's do the last one. And plug our ones in there, so we'll do it from a binary perspective this time. Now this is a cute one. 192.168.10.255. That was the broadcast address for the parent network. The original network we started underneath here with was 192.168.10.0 was the network number. The subnet mask stopped there. The network number was there. The actual broadcast address is 255 in this last octet, and you can work that out, all ones. So when we subnet, the last network will have the same broadcast address, and the first network will have the same network number as the parent. And there were issues ages ago in routing where you couldn't actually use this network or use the last network because of that, but routers have solved that quite happily ages ago. So let's go into the binary here and say, well, that's adding 1 to that value there, which is our first available host address, and let's subtract 1 off our last value that we're available to use, which is that one. So that's correct. So if we add that up in decimal, then our last available address is 254, and our first available address 193 for that network. So that is fixed length subnet masks. Couple of things to finish up on. What is the actual subnet mask going to be? It's this value up here. So for each of these networks, the subnet mask is going to be what we've extended. It's got 2 extra bits. So there's now 26 bits in the subnet mask. So let's just pop it down here and we'll put it in here. So we'll kill this kind of network that we had before. 192 is actually going to be in the last octet. So for each of these subnetted networks, we've got 8 ones, which is 255, and another 8 ones, which is another 255, and another 8 ones, another 255. In this case, we've only got 2 ones, which is 192. That is the subnet mask, 255, 255, 255, 192 for each of these networks. Now, as a test, the subnet mask is always going to be the same value, if you like, as the network number of the last one. Let's do another little test. Let me just sum. I think sum's over here somewhere. Where's my functions? Sum that range there, and hit enter. 248. So 248 is the number of hosts that we are left with, because there's 62 in this network, 62 in that network, 62 in that network, and 62 in that network. So that is correct. When we started with our C-class network of 192.168.10.0 with 24 bits in the subnet mask, we actually had 254 available hosts. We've lost 6. And we've lost them in there. So previously our range went from 1 to 254, but now we've got these little addresses that we cannot use because they are the broadcast for that network, the network number for that network, the broadcast for that second network, and the network number for that network. We've lost 6 different values. 1, 2, 3, 4, 5, 6 have been taken out of our initial pool, and that's a nice little check to know that we're actually correct as well. So a little bit in that. Make sure you're comfortable with your converting binary to decimal, and when you work through this, be very, very logical. You see I've jumped ahead a bit, I haven't copied this lot down. The parent always stays the same when we subnet. So 192.168.10, that binary will always stay the same. I don't know why I did that. So that stuff stays the same, even the subnet mask of the original stays the same as well. And then we say, I want 4 new networks. How do I know that 2 bits will get me 4 new networks? Well, I can do the math, which is 2 to the power of 2 will give me 4 new networks. If I want 8 new networks, I do 2 to the power of 3, and I add an extra bit in my subnet mask there, and then those 3 bits becomes network numbers, and I'll end up with 8 different networks. But this is the key here, is to work out, okay, I'm going to extend my bits, and they always extend from the 1s. You don't put any zeros in your subnet mask, so it's all 1s and then all zeros, and those 2 values, which I've got in yellow there, become network numbers, so they're subnetted bits. So we start with the first one, 0, 0, then we go 0, 1, 1, 0, and 1, 1. Let me just finish on one little thing here, just to show you. What I'm going to do is create the binary values if I had 3 bits in the subnet mask, just to finish off. Now, I'm kind of going to cheat a little bit, because I know that if I've got 3 bits in the subnet mask, I'll have 8 different values. And those 8 values will always follow a particular pattern. In fact, whenever we subnet or add a number of bits to binary, it'll always follow this pattern. The right hand column will always be 0, 1, 0, 1, 0, 1. The next column is going to be 0, 0 and 1, 1. And next one goes down there. So this column on the right is 0, 1, 0, 1, 0, 1. The next column is always going to be 0, 0, 1, 1. And because we're binary and everything doubles all the time, then the next column is going to be that value. And there I've got 8 different values from 3 bits. I started with zeros and I've ended with 1. And all I've done is actually added a 1 to the first value each time. And that's the pattern that you end up with. So the pattern is a nice thing to try and remember. You can actually see the pattern back up in here. 0, 0, 0, 1, 1, 0, 1, 1. Let's pull it out. Let's copy that. And then we'll get our 0, 1. We'll get our 1, 0. And our 1, 1. So there's our pattern. See there and there? 0, 0, 1, 1. 0, 0, 1, 1. 0, 1, 0, 1. 0, 1, 0, 1. So from a subnetting perspective, this pattern extends. If I wanted to take 4 bits, I can then copy that whole pattern and go plop, and then all I do is add a bunch of zeros to, I'll get to there, and then I'm all 1s. So handy little thing remembering this pattern. it helps you double check. The other thing it is, it's always adding 1 to the zeros. Now that 1 is not, when I say a 1, it's the binary one. In our case up here, we've added 64 to each of these subnets. So 0 plus 64 equals 64, plus 64, 128, plus 64, 192. I've added 3 bits down here, so what I'm actually adding is the third one there. So I'm adding a 1 in the 32 column. So be careful of that. Let me get rid of that fourth one there, just to, because let's go back to this one. Sorry for jumping around there. So if this was 128, 64, 32, then these values will be 0, 32, 32 plus 32 equals 64, plus 32 equals 96, plus 32, 128, plus 32, 160, plus 32, 192, plus 32, 224. So these become the network numbers if we were to have used 3 bits. So there's probably not explained particularly well there, but keep looking at it and you'll be able to work it out. Let me go back to this one actually. So if this was 128, I'm thinking on the fly now, aren't I? 64. So that was our first value, was zeros, so that's 0. And then the next bit across is in the 64 column. So that's 64. 64 plus 64 is 128. 64 plus 128 is 192. And that's what we've done there. And you'll notice there's repetition. 64, 64. And that's half, 32. 128 is also in there. 192 is in there. There's only ever a set number of actual values you can have. And there it is. That is subnetting. So we've subnetted a C class address and it's fixed length. We've only added in this case 2 bits, but I'll invite you to add 3 bits and go through the same process. Create your network number, find your broadcast by adding up all the ones that are in the host portion, and then you add 1 to the network number to find the first available address, and you subtract 1 off your broadcast to give you the last available address for your network. So practice that, make sure you get comfortable with that. Handy, very handy thing to do, particularly if you want to pass your CCNA. Thanks for listening. Catch you later.